This is question 7 from paper 2-1 from the summer 2020 exams from Cambridge International Education. You can find a link to an image of this question in the description below this video, and I recommend you try the question first before looking at the solution. The first thing that confused a lot of students about this question was actually the English involved. The question says, find the quotient when this equation here is divided by this one and show that the remainder is 9. So what did that mean? All it means is this is divided by this. Well, they said that. This is divided by this. Find the quotient and the remainder. Just a quick example of that with some normal numbers, maybe 7 divided by 2 is equal to 3 with a remainder of 1. We get something similar here. We're going to, this divided into this will be equal to something in x's. Let's see, x goes into x cubed, something with x squared, ax squared plus bx plus some number c, and it's going to have another remainder d. And this would be just some numbers here. When it goes in perfectly, we get a remainder of 0. Actually, in this case, instead of d, I could just write 9, because they told us the answer is going to be 9. So that's all we need to do. We just need to go ahead and divide this into this. How we do that is actually quite similar to something we've done since we're quite young, long division, or an algorithm for long division. So we take this one and divide it into this term here. 9x cubed minus 6x squared minus 20x plus 1. Okay, so how it goes is we think to ourselves, something must multiply 3x to make 9x cubed. And we're going to do this all the way along until we're left to the very last one. And unfortunately, nothing will quite work for the last one. And that's where we're going to get a remainder. Okay, so what can multiply by 3x to make this? Because we're dividing here. So the opposite of divide is multiply. So 3 times 3 would make 9. X times another 2x's, or x squared, will make this. Okay, so 3x squared multiplied by 3x will give us 9x cubed, just like we wanted. But then if we stay multiplying, we multiply it by the 2, we would get, this should be a minus there, we get plus 6x squared. And that's all we usually write. You can go ahead and, I guess, multiply 3x squared by the next number, which is 0, and the next number, which is 0, if you'd like this to match up every time. But mostly we just ignore those 2 parts. Okay, so that's not quite perfect. It's nearly perfect. We take this away from that, has remainder 0, but this doesn't. Minus 6 minus another plus 6, we get minus 12x squared. So it wasn't quite perfect. It was close though. And we can stay doing this the whole way down, minus 20x. Usually that's all we do. We just take 2 terms because we just need 2 terms. But you can go ahead and take them all down, I suppose. Plus 1. Okay, so we think to ourselves, what would multiply by this to fit perfectly at the start of this one? Okay, so what multiplies by 3 to get 12? Must be a 4. It must need a minus to get there. And we need an extra x to get there. And again, we multiply this by the 3x, we get minus 12x squared. Minus 4x times the 2 will get us a minus 8x. And how close is this? Let's take it away. It has a remainder 0. Minus 20 minus 8 is, that's plus 8 onto minus 20, which is minus a 12x, which is the same as that one was. And I guess, again, like I said, you could have a 0 here if you want. We usually don't do this part. I just, for whatever reason, I guess I'm doing it now. It shouldn't change anything. Okay, what multiplies by the 3x to get this? It's a minus 4 again. And no x needed this time. And minus 4 times 3x is minus 12x. Minus 4 times 2 is minus 8. So this goes in perfectly on this bit, but on the last bit, it doesn't go in perfectly. 1 minus minus 8 is 9. Remainder 9, plus 9, I'll leave it there. We can't stay going because there's no more numbers to go. There's only zeros left there, and zeros aren't going to get us any closer to the right answer. Okay, so the answer here is the quotient. I don't know how to spell quotient, so apologies if that's wrong. The quotient is this number here. So think of over here for an example. 2 goes into 7 3 times with remainder 1. 3x plus 2 goes into this term here this much. So the quotient is 3x squared minus 4x minus 4. And the remainder, I also don't know how to spell this. Apologies, I'm a maths teacher, not a spelling teacher. And the remainder is 9. That's full marks for part A. Now, I'll rub all this out and we'll do part B. I think I will leave this here. I need this part for part B or maybe part C. Right, part B asks us to do this integral here. This is a very complicated and hard integral, except we just did part A. And these are the same things that were in part A. So we know what this divided into this looks like. At least we sort of do. We're going to have to remember a few things from this. Let me put back the example here. 7 divided by 2. I had a quotient of 3 and a remainder of 1. So I could actually say, or if we learn how to read this, 7 over 2 is actually equal to 3 plus 1 over the original divider. 1 over 2. And that 7 over 2 is 3.5. Again, we can rewrite this as the quotient here, 3x squared minus 4x minus 4 plus the remainder 9 divided by 3x plus 2. And let me put a bracket in here and keep the dx. And we're still going to integrate between 1 and 6. Okay, so this is a lot more manageable than this one here. Most of this, I'll have a bit of trouble with this part here, but other than that, we should be able to manage this. So let's try and integrate this. 3x squared, the integral of, I always start with x squared. X squared becomes x cubed. This number we divide by. So 3 divided by 3 becomes 1. Okay, next one, we have x and it becomes x to the power of 2. So we get minus 4 divided by 2 is minus 2. And the next one, there's always an x to the power of 0. Wherever you see a 1, and this is multiplied by 1, there's actually an x to the power of 0. Okay, so the x becomes 1 bigger. So it's a 1 there I'll put in. And minus 4 divided by 1 is minus 4. Okay, so that's these ones, the easy ones. What about this one? So lots of students will know the answer straight away. It's not a very difficult one actually. But for me, I'll show you how to do it on its own by over here at the side. So let's just take this one little sum here. The integral of 9 over 3x plus 2 dx. So how we do this is we replace this one here with just a u. U is equal to 3x plus 2. We do this a lot in integration. If something looks too difficult, just replace it with something that looks simpler. It's not always going to work. You have to start getting used to how and when to do it. In this case, if I replace this with this. But that means dx now becomes meaningless. So to fix that, we get du dx is equal, and we just differentiate, and that's actually simple enough. It's 3. That's one of the reasons I picked this. It's nice and simple. So if I rearrange this, I'll just get dx comes up here, 3 goes down there, and dx is equal to a third du. So now I can replace this entirely. Instead of, let me put it here, instead of this integral, I now have an integral of 9 over u du, sorry, 1/3 du, which is the same as the integral of 3 over u du, which is the same as, the 3 can come out front, 1 over u du. Now this is quite a famous integral, 1 over u. That is quite simply, the answer is just 3 natural log of u plus a constant, which won't matter here because we have actual numbers. So, and again, u is just made up. Just replace this. Do I have room? I guess I'll squeeze it in. 3 times 3x, oh my bad, 3 times the natural log of 3x plus 2. Anyway, a lot of students will just look at this and say, Well, that's the natural log of 3x plus 2 multiplied by the derivative of inside here, or sorry, divided by it. So divided by 3. 9 divided by 3. That's where we got this outside 3 here. So this just, so I can just look straight at this, and how I would often write this if I was doing it myself, I just write plus 9 natural log 3x plus 2, and then I'd look at this 3 and I'd divide by 3. So that's how I'd quite quickly get that in my head. Alright, we're still not done. We still have to evaluate this between 6 and 1. Still, you're getting lots of marks for at this point here. And now I'll go ahead and cheat and use my notes for this part. Between to evaluate between 6 and 1, we need to put a 6 in here. 6 to the power of 3 minus 2 times 6 to the power of 2 minus 4 times 6. All that would come out as 120. Then I put 6 in here. I get 3 6s are 18 plus 2 is 20. Natural log of 20. So plus 3 natural log 20. Then I need to take away, let's minus, and I just make a big bracket usually here. Put 1 in for all of these guys, and I would get minus 5. 1 minus 2 minus 4 is minus 5. Yeah, that's easy to do actually. And then I'd get plus 3 times natural log of 3 plus 2 is 5. We can clean this up a lot here. We get 120 minus 5 is 125. And let's see, we have 3 times the natural log of 20. And we also have, minus 3 times the natural log of 5. Our rules about natural logs, when they take away, or any logs with the same base, in this case they have the same base, log to the base e, that's what a natural log is. We just get, this is just equal to 125 plus 3 times the natural log of these two numbers divided. 20 divided by 5, which is 4. And let me just double check that is the answer. They don't want it that way. In the exam they asked the answer to look like this a plus natural log b. So while this is the correct answer, it doesn't quite look like they wanted a. That's okay. They want a 1 in front of the natural log, so I better clean that up. This is 125. I'm going to run a little bit out of room the way I've done it. 125 plus natural log of 4 to the power of 3. Because that's another rule for logs. There's 3 multiplied out here is the same as 4 to the power of 3. Well, 4 to the power of 3 is just 2 to the power of 6, which is 8 times 8, I guess, 64. So that's our full answer for part B. 125 plus natural log of 24. Okay, if you have any questions about that, put them in the comments below. Otherwise, I will rub this out and move on to part C. Okay, in part C, they give us this nasty looking equation. 9 multiplied by the exponential of 9 multiplied by y, and so on, equals 0. It looks very scary to a lot of students. I'm sure a lot of students just threw their hands up and said, I can't do that. But what you needed to notice is this is very similar to the first question. We have 9 times something, minus 6, minus 20, minus 20. This is different, plus 1 and a minus 8. That's going to be important as well. Also, the real trick to notice here is the x's are similar to these as well. If we make one substitution. So it's easiest to see when there's just an x here and there's just this here. So x is equal to e to the 3y. It does work. I'll show you why now. So it might look like it's okay here. X and this, they're in the same spot. But x squared doesn't equal this, or does it? Let's find out. X squared is equal e to the 3y squared. And our rules for powers is the power, if a power of something with a power, the two powers multiply. So 2 multiplied by 3 6 is equal to e to the 6y, which is what was here. So if x equals this, this still works. This is still identical to this guy. and x cubed would therefore be 3 multiplied by 3y, which is e to the 9y, which again is still what's here. So this question is very similar to this one here. If only, oh, let me leave that somewhere. X is equal to e to the 3y. If only that's true, which it is, or we can just put it through, this works quite nicely, except for this 8 and this 1. Now what you need to notice is the difference there is 9. So plus 1 and minus 8, they're 9 away from each other. And remember what we got earlier up here. This divided by this was equal to this quotient with a remainder 9. So it had 9 too many basically. This had 9 too many to divide in perfectly. Well, this has 9 less. So I now know this divided, well, let me rub out the equals here. This divided by this one here, 3 times e to the 3y, instead of x, I'm putting that going in, plus 2, divides in perfectly, is equal to this one here. I shouldn't really write all that out like this, but I think hopefully it's getting my point across. Minus 4 e to the 3y minus 4. If it divides in perfectly, there's no remainders here. But we don't have to use all these ey's. We can go back to just using x's. So let me just rub out all these. So there, by the magic of editing, we just have x's here. This divides in perfectly here. And they want us to find the exact root. Basically, just want to find out what x equals. There should be 3 answers for x. Find out what that equals, except we don't want x anymore. We're going to look for y. But let's just get x first, and it's easy enough to find y then. Okay, so if this divides in and equals that, let's just multiply this over here. So 3x plus 2, we just get 3x plus 2. So that's how we factorize. That's one of the ways we factorize. We just divide something in to get the other factors. So this is equal to these two factors. Or we can separate this one out. Let's see, we should be able to break this up. So 3x plus 2, this one we knew. Let's break this one up into 3x and x. That's what would make 3x squared. Now, two numbers that make 4. Could be 4 and 1. Let's see, that'd make 12 and a 1. Hard to get 4 with that. It could be 1 and 4. That's 3 and that would be 4. No, it can make 7, could make 1. Can't make that. 2 and 2. Let's see, 2 by 3 is 6. 2 by 1 is 2. That will make a 4. Hopefully if we can get the signs to work. Let's see, we need minus 4. So I think I would want plus 6. So this would be plus 2 times plus 3 plus 6 minus 2x. That'll make this one. And let's check our work. Will all work for this guy? Minus 2 times plus 2 is minus 4. Okay, so there are the 3 factors for this. And remember, we all already know this equals 0. So this guy here equals 0. So we get 3 answers. We get x is equal to, should I have a minus here? Let me just double check that. No, I shouldn't have a minus. Hopefully you guys noticed my mistake a little earlier. I said 2 times 3 is 6 minus 2. That doesn't make 4. I wanted minus 4. So I was looking for a minus 6. So minus 2 times 3 minus 6x plus 2. That's what I was looking for to make 4. I've already done the answer, so I knew this wasn't right, because I knew this was actually the same as this guy here. Either way, we get 3 answers. We get x is equal to minus 2 over 3. If we just solve this. Another answer is x is equal to 2. Just solving that. Each of these is equal to 0. And, well, this last one's the same as this one here. So I guess we get 2 answers. Don't have to write it out again. X is equal to minus 2 over 3, or x is equal to 2. Now again, we didn't want x though, we want y. So here's y here. So what we really get is e to the 3y is equal to 2. Or let's do it again here. E to the 3y is equal to minus 2 over 3. Now this one's a problem. This one doesn't have an answer. Because nothing, there's nothing I can think of, except for imaginary numbers, that we can put e to the power of to get a minus number. It just doesn't work. E is just a number, it's 2.7 or so. And no matter what we put 2.7 to the power of, it will always be bigger than 0. Unless if y is like minus infinity, it will be 0, it'll get close to 0. Well, it'll never get to a minus. So this one has no answer. So that's not the answer. This one, on the other hand, does. If we get rid of e, we take the natural log of both sides. Natural log of e destroys it, is equal to the natural log of 2. And then we just divide both sides by 3. Y is equal to 1 over 3 natural log of 2. And that's our full answer. That's the answer they were looking for. Did they ask for it in any... oh, they asked for exact. So be careful there. When they ask for exact, they don't want decimal places. They want the exact answer. So you're probably going to be using pi, natural logs, exponentials. That's what they mean by exact. Alright, I hope that answered all your questions. Like I said already in the middle, if you do have any follow-up questions, if there's anything you're not sure on, maybe I didn't explain it the best, let me know in the comments below and I'll do my best to answer you.